Hey everybody, my name is Calvin and welcome back to my channel. In this video, I'm going to be working through a LeetCode medium the way I would in a real coding technical interview. The point of this video is to show the thinking process in real time and not just the finished answer. It's important because in interviews, interviewers are going to be paying attention to more than whether your code works. They want to see how you approach the problem, how clearly you communicate, and how you can handle your reasoning under pressure. A lot of candidates practice LeetCode by solving problems silently and then checking whether they got accepted. Sure, that helps to some degree, but it doesn't fully prepare you for the interview itself because in the interview, you need to make your reasoning visible to the interviewer. So for this video, I wanted to model that process directly. Say you've been given a Leetcode-style question called longest substring without repeating characters. The first thing I want to do here is to make sure I understand the question correctly. We're given a string s, and we want to find the length of the longest substring without duplicate characters. So, in other words, I'm looking for the longest contiguous section of the string where every character is unique, and I need only the length. Looking at the examples, it seems rather straightforward. For the first example, the answer is 3 because the string ABC works. For the second example, the answer is 1. For our third example, the answer is 3 because we know that WKE is valid. But something like PWKE would not count since it is not contiguous. To start, it's always a good idea to map out the naive approach just to establish a baseline. The most direct way to solve this would be to generate every possible substring and check whether it has all unique characters, and then track the maximum length. So let's sketch that first. We'll have a variable called maxLength, and we'll set that to 0. This is just setting up my answer variable. This is going to store the best length that I've seen so far. Now, I want to generate every possible substring, so we'll use 2 loops. The first loop will pick the starting index, and the second loop will pick the ending index. Our first loop will be for I in range length of s, and then for our second loop, for j in range I length s. Now, inside these loops, I want to slice out the substring from I through j. Or we can do that by doing this. Substring is equal to s index I j plus 1. And that will represent our substring. And now, I need to take this substring and check whether that substring contains all unique characters. A quick way to do that would be to compare the length of the substring to the length of a set made from it. If they are equal, then there were no duplicates. We can do that like this. If length of set substring is equal to the length of the substring, the max length is equal to the max of max length and the length of the substring. And then finally, we'll return max length. This would work theoretically. I'm generating every possible substring, checking whether it is valid, and updating my answer if it is. Let's see if this works. And now we can see we've exceeded our time limit. This is because this is a very inefficient way to solve the problem. Theoretically, we know that. The reason is that there are a lot of substrings, about O of n squared, and then for each substring, I'm building a set, which can take up to O of n time. So, in this case, this is roughly O of n cubed in the worst case, and that's way too expensive for this problem. Seeing the solution, I know that one way to improve the performance is to mitigate the repeated work. A lot of these substrings overlap, so instead of recomputing everything from scratch every time, I want to maintain a current valid substring as I move through the string. My LeetCode practice tells me that sliding window is often the better approach in this specific problem. So, in this case, we're going to replace this with a solution that uses 2 pointers and a set. At a high-level overview, I'll keep a window from left to right, and then the set will store the characters that are currently within that window. Let's set that up. Let's get rid of our naive solution, and we'll have a set called scene, and we'll have our left pointer initiated to 0. Whoops. And then we'll have our max length is also set to 0. Scene is going to hold the characters that are currently in my window. Left will mark the start of the window, and then the max length still stores the best answer I've seen so far. Now, I want to move right across the string 1 character at a time. What do I mean here? For right in range length of s, we're going to be looping through this. And here, at each step, I want to check whether the current character is already inside my window. If it is, then the window is no longer valid because then I would have a duplicate. So, in that case, I need to move left forward and remove characters from the set until the duplicate is gone. So here, we can do that with a while loop, while s of index right in scene dot remove from the set s left. And then here, we can increment our leftmost pointer by 1. Here, the while loop is the key part. It keeps shrinking the window down from the left until the s at right index is no longer duplicated inside the correct window. Once that is true, I can safely add the current character. And we can do that with scene.add s at index right. And once I add it, my window is valid again, so I can compute the current window size and update my answer. Max length is equal to the max of max length right minus left plus 1. And then we return max length. And now, this is a more optimized version. The invariant I'm maintaining is that everything inside the current window is unique. If I ever hit a duplicate, I simply just shrink the window from the left until it becomes valid again. Then, I add the current character and update the maximum window length. Let's walk through an example. Say the input is A, B, C, A, B, C, B, B. I add A, so the window length is 1. Then, we'll add B, so now it is 2. Then I add C, so now it is 3. Then I see another A. Since A is already in the set, I go into the while loop and start removing characters from the left side. I remove that old A, move left up, and now the duplicate is gone. Then I add the new A and continue. At every step, the window stays valid, and I only ever move both pointers forward. The brute force solution was O of n cubed in the worst case. Now, this optimized solution is O of n time, because each character gets added to the set at most once and removed at most once. Even though there is a nested while loop, both pointers only move forward across the string overall. The space complexity is O of n in the worst case if the window contains all unique characters. Let's run this, and we'll see the performance improve. And here we see that our solution works. And now we have a lot better performance because now we don't have timeout exceeded. This is usually a good game plan for technical interviews. Starting with a brute force approach helps you reason through the problem at first and understand how it works at the very basis level. Then, taking that brute force solution, you can reason through the solution and optimize for the problem. Of course, if you know the answer already, as long as you can reason it out the first time, it should be fine in an interview. But if you are caught off guard, starting with this approach, with the brute force approach, is often good, because then you'll have at least some working solution, and then working on optimizing it. That's a lot of what software engineering is. Code often goes through many iterations, and the goal of every iteration is to make it so every iteration is better than the last. And that's what we did here today. If you found this video helpful, be sure to like, comment, and subscribe, and be sure to check out my book Modern Data from Ingestion to Production that is available on Amazon, Apple Books, and Barnes & Nobles. Link in the description. Thanks for watching, and I'll see you guys next time.